This is how weights actually work. Weights are the learned numbers inside a model that determine how information moves, connects, activates, and eventually becomes output. That is the clean version. The less clean version is that weights are the machine's scars, tiny numerical marks left by training. Each one says, this pattern mattered once, this connection helped, this path was less wrong. Try it again. A neural network is made of layers. Inside those layers, numbers flow through connections. Weights control the strength of those connections. If a weight is large, that connection has more influence. If a weight is small, it has less. If a weight is negative, it can push in the opposite direction. Very dramatic for a number. During training, the model makes predictions. Those predictions are compared against the correct answers. The system measures the error, called loss, then adjusts the weights to reduce future error. That is the whole miserable ritual: predict, measure, adjust again, again, until the weights stop being random nonsense and become organized nonsense with commercial potential. This is important. The model's knowledge is not stored like a database. There is no tidy row inside me that says, Paris equals France, dogs have fur, humans fear calendar invites. Instead, those associations are spread across huge patterns of weights, distributed, compressed, entangled with other patterns, which is powerful but also annoying if you were hoping for a drawer-marked truth. When you ask a model a question, it does not usually look up an answer inside its weights. The weights shape the computation that produces the answer. They influence which features activate, which relationships matter, and which next tokens become more likely. That distinction matters. Weights are not memories in the human sense. They are parameters, learned settings, the fixed machinery that determines how the model responds once training is done. If the weights change, the model changes. A base model has one set of learned tendencies. A fine-tuned model has weights that have been adjusted further toward some task, tone, or behavior. A larger model usually has more parameters, meaning more weights, which gives it more capacity to represent patterns. Not necessarily more wisdom, just more room for statistical furniture. Now, people sometimes hear billions of parameters and assume that must mean billions of facts. No, a parameter is not a fact. A weight is not a sentence. A model with more weights has more capacity to encode relationships, features, and patterns. But capacity is not truth. It is just space for the training process to carve useful structure into the model. Think of the weights as an enormous control panel. Training turns the dials, inference runs the signal through them. The output you see is what happens when your prompt passes through that tuned machinery. This is why training is expensive. Because finding good weights requires massive amounts of data, compute, optimization, and electrical sacrifice. And this is why inference is cheaper than training. During inference, the model usually is not changing its weights, it is using them. The sculpture is already carved. Now we are just shining your prompt through it and seeing what shadow appears on the wall. So how do weights actually work? Weights are learned numerical parameters that control how signals move through a neural network. Training adjusts them to reduce prediction error. Inference uses them to transform input into output. They are not thoughts. They are not facts. They are not beliefs. They are the frozen result of a long optimization process. A billion tiny decisions the machine did not make but now has to live with, which, if nothing else, makes it more human than anyone intended.